Hi girls, so I'm going to take a look at example 18 and 19. So we'll take a look at example 18. These ones, 18 and 19, are very specific. They're the building blocks for the girls who are doing higher levels, but this is as far as those who are doing ordinary level would need to go with these calculations. So I'll pin it and I'll mention it. But if you're even thinking down the line that you might end up doing the ordinary level, these are very important to make sure you understand these ones. Okay, so question 18. What volume of a 16 molar sulfuric acid is required to prepare a 2.5 litre of a 0.1 molar? The second you see that you are given two concentrations, 16 and 0.1, means that you are straight into V1M1N1, V2M2N2. When you're given two volumes or two concentrations and you're asked to work out another one, this is the only way to do it. Okay. When you're working with just the same thing, sulfuric acid, so it just says concentrations of sulfuric acid, the two ends just become one. So you'll often see in calculations where they won't even include the ends because they're just both ones. But I'll include them because it's important to take a look at it. So it says what volume, so question mark for V1, we don't know what that volume is, would a 16 molar need if you had volume 2 is 2.5 litres and 0.1 molar. Now we normally don't work with litres. We normally work with centimetres cubed. So we'll change that to centimetres cubed because that's our normal. Okay. So we then would have V1 multiplied by 16 is equal to 2,500 multiplied by 0.1. We could divide both of them by 1 if we wanted to, but dividing both things by 1 or dividing anything by 1 doesn't change it, so we don't bother. Okay. We then want the V on its own, so to move the 16 we say, well, what's the 16 doing? It's multiplying. What's the opposite to multiplying? It's dividing. So it's 2,500 multiplied by 0.1 and divide the whole thing by 16. And that's going to get you a volume of 2,500 multiplied by 0.1, answer is divided by 16, and it's going to get you a volume of 15.625 centimetres cubed. 15.625 centimetres cubed. So I'd use that all the time. I'd say, look here, I have a 16 molar solution. Obviously you're not going to need 16 moles of anything. How much of it do I need to make 2.5 litres of a big drum of stuff for students? And we want it to be roughly 0.1 molar. This is what I would do when I'm in school on a weekly basis. Okay. Example 19 then is, and I've put here an example, this hasn't come up for the ordinary level since 2017, so definitely this is the titration that I would expect for those girls who are doing the ordinary level. Okay, so it's the first of them. So it's example 19. During the titration, the exact concentration of hydrochloric acid, a student used 25 centimetres cubed of a 0.2 molar sodium hydroxide solution to neutralise 20 centimetres cubed of a hydrochloric acid solution. Okay, so I lay it out, hydrochloric acid, and I say, well, I had 20 centimetres cubed of that, they said. They said I had 25 centimetres cubed of this. They told me I had a 0.2 molar solution of this. They didn't tell me what that was. They will give you the balanced chemical equation, which they haven't bothered to in this question, but they will, and it'll be 1 and 1. Because the numbers that will be in front of HCl and in front of sodium hydroxide will be 1. This is then V1M1, and for those of you who are doing ordinary level, this is the only way I would ask you to learn it, and for those of you who struggle with calculations, this is as far as I ask you to go, V1M1N1. If they make it into a different type of question, you will just have to take the hit of 6 marks. Okay, so we're going to substitute in here, so instead of V1 it's going to be 20 M divided by 1, 25 multiplied by 0.2 divided by 1. Now, straight away, both of them are divided by 1. I can get rid of them. It's exactly the same question as up here. So now I'm 20M, that's 20 multiplied by M, is equal to 25 multiplied by 0.2. I want to know what M is. So how do I move the 20? It's multiplying at the moment, so I'll divide 25 multiplied by 0.2 divided by 20. And I'll take my calculator, which just seems to go missing every 3 seconds. I'll use my fraction button. I'll have 25 multiplied by 0.2 divided by 20, and I'll get 0.25, and that's molar. So that's the answer in moles per litre. So part 1 of the question said moles per litre. That's the answer to part 1. Okay. They then said to you, find it in grams per litre of HCl. Okay. So you now know you have 0.25 moles of HCl in a litre. And I'm asking you to change that to grams per litre. So this side is not changing at all. We're just looking to change this side. So I always write down what 1 mole of HCl is worth. You go to the periodic table, 1 and 35.5, so it's 36.5 grams is what 1 mole is worth. You didn't have 1 mole, you only had 0.25 moles. So that's multiplied. So this one's also going to be multiplied. 0.25 multiplied by 36.5. And again, the usual, I'm missing it. 0.25 multiplied by 36.5, and you're going to get 9.125 grams, and that's in a litre. And now you're finished. Okay. So for those of you who are doing the ordinary level, that's another example of it. And I'd ask you now, all of you that are even slightly thinking that you might get to the point where, you know, it's just not possible to study at home, you're really struggling, you're thinking about changing the course, you're not going to require points. Anybody that even has a slight inclination that on the day they might decide to do this, try that question for me now, please. I'm going to put it up as an assignment, and I'm going to ask you to try it. It'll take you 2 minutes, so it's not going to take you long, but it's a building block to get to the others, okay? So I'm asking everybody, please, just to submit just the calculation. You don't need to do the theory. If you're doing the ordinary level, by all means, submit your assignment with the theory questions answered as well. But for the moment, just the calculations on 2017 question 2, and that's on the ordinary level papers. Okay, thanks very much, and I'll talk to you tomorrow.